Hello everyone. Welcome to the class of Highway Survey and Design. I'm Wen Jiaqiang, the main lecturer. Vertical curve design mainly includes the definition of vertical curves, elements and calculation formulas of vertical curves, determination of the minimum radius and length of vertical curves, key points of vertical curve design, and vertical curve calculations covering 5 areas. Today, we will learn the first 4 topics. First, let's look at a definition of a vertical curve. As we all know, the driving experience over a grade change point is not smooth. To ensure a smooth ride, a curve is usually used in longitudinal profile design process to ease the connection between the 2 longitudinal slope lines before and after the grade change point, which is called a vertical curve. Vertical curves are characterized as convex vertical curves and concave vertical curves. How do we determine this? If the slope rotation angle corresponding to the vertical curve is greater than 0, it is a convex vertical curve. If less than 0, it is a concave vertical curve. From the definition of vertical curves, we know that the profile design line consists of straight lines and vertical curves. In China, a second-order parabola is commonly used for vertical curves. Going forward along the route, we call the tangent points of the straight line and the parabola the beginning and end of the vertical curve, denoted by the capital letters QD and ZD. The length of the parabola from the starting to the ending point is called the length of the vertical curve, represented by the capital letter L. The tangent length from the beginning or end to the grade change point is called the tangent length, denoted by the capital letter T. The curvature radius at the apex of the parabola is called the radius of the vertical curve, represented by the capital letter R. Within the vertical curve, the distance from any point before the change of slope to the beginning, or any point after the grade change point to the end, is called the horizontal distance, denoted by the lowercase letter l. Taking 0 elevation as a base, the tangent elevation at any point within the vertical curve is called tangent elevation, represented by HQ. The absolute difference between the design elevation and the tangent elevation at any point within the vertical curve is called vertical distance, denoted by the lowercase letter h. Obviously, in the vertical curve, the vertical distance is greatest at the grade change point, called the external distance, represented by the capital letter E. Based on the basic equation of a parabola, x squared equals 2p times y, we can deduce 1. The length of the vertical curve L equals r times the absolute value of the slope rotation angle. 2. The tangent length t equals half the length of the curve, and the external distance E equals the square of the tangent length divided by 2r. The vertical distance h from any point on the vertical curve to the corresponding tangent is equal to the square of the horizontal distance divided by 2r. Note that on the vertical curve, any point before the grade change point has a horizontal distance to the beginning. After the change of slope, the horizontal distance is to the end. Next, we learn about the determination of the minimum radius and length of vertical curves. The minimum radius of a vertical curve is mainly influenced by 3 factors. 1. Easing shock. 2. Requirements for driving side distance. 3. Time requirements for driving. In addition, concave vertical curves are also subject to headlight illumination distance requirements. Based on the requirements of easing driving shock and ensuring driving side distance, The determined minimum vertical curve radius is called the limit value of the vertical curve radius. Note that according to road design experience, unless conditions are limited, we should not easily use the limit value of the vertical curve radius, but rather 1.5 to 2.0 times this value, called the general value of the vertical curve radius. To ensure driving comfort, China uses a distance covered by a car traveling at design speed for 3 seconds as the minimum length of a vertical curve. Therefore, the design standard for highway alignment, Table 8.6.1, stipulates the minimum radius of vertical curves and length of vertical curves, which must be strictly adhered to in practice. Finally, we learn the key points of vertical curve design. Key point 1. In vertical curve design, an appropriate radius should first be determined. According to the design experience of corporate mentors, choose a radius that is greater than or equal to the radius listed in the following table without excessively increasing the project volume. Key point 2. For vertical curves in the same direction, especially two concave vertical curves, if the straight slope section approaches or reaches the minimum slope length, they should be combined into a single curve or compound curve. Key point 3. A straight slope section should be set between reverse vertical curves, typically no less than the distance covered in 3 seconds at the design speed. Key point 4. The setting of vertical curves should meet drainage needs. About vertical curve design, today we have learned the definition of vertical curves, the elements and calculation formulas of vertical curves, the determination of the minimum radius and length of vertical curves, and the key points of vertical curve design. In the next lesson, we will learn how to calculate vertical curves.